Big O notation is a mathematical notation that describes the limiting behavior of a function when the argument tends towards a particular value or infinity. In computer science, Big O notation is used to classify algorithms according to how their runtime or space requirements grow as the input size grows. Big O notation characterizes functions according to their growth rates. So, the different functions with the same growth rate may be represented using the same O notation. The letter O used because the growth rate of a function is also referred to as an order of a function. So O is the order of a function. Okay? Now, a description of a function in terms of Big O notation usually only provides an upper bound on the growth rate of a function. So, if we have a function, we have lower bound and upper bound. Also, if we have an algorithm, we have the lower bound and the upper bound, which we have take an example in the previous video that we have an algorithm that can be executed by 1 second and another algorithm that do the same result and the same computation in 10 seconds. So the lower bound is 1 second in this case, and the upper bound is 10 seconds in this case. So we are going to, and we are interested in understanding and studying this upper bound. We don't care about the lower bound. So in computers engineering, we don't care about the best case. We need the worst case to make it, to lower its order, to make it better and better. So the upper bound is denoted by O. So associated with Big O notation are several related notation using the symbol like O, omega, theta, and much more to describe other kinds of bound to asymptotic growth rate. Okay? So let's assume this notation gives the tight upper bound of a given function. Generally, it is represented as f of n equal to O of g of n. This means at larger values of n, the upper bound of f of n is g of n. We are not going to make a deep representation in mathematics, but I'm just telling you that this Big O notation is the highest order in the function. Okay, so if you have n to power 4 plus n to power 3 plus n to power 2, we took n to power 4 as its representing value. Don't worry, in the next videos, we are going to make an example about exercises about Big O notation, and we will clarify all of these things. I need from you to take a quick look about this lower bound, average time, and upper bound, and these algorithm time. So we start by O of 1 and O log n. So this is the green O of 1. This is the greenish log n. This is the yellow O of n. So see guys, we are moving from the linear O n log n and n to n log n. You see the difference here, and we start by excellent. This is O of 1, excellent. Good, log n. Fair is O of n. These algorithms are good. While n log n is bad. And the horrible things that we may encounter is O of n to power n square, O of 2 to power n, and n factorial. Your mission, and you are asked to make the horrible notations and horrible algorithms like good and fair and maybe excellent algorithms. So your mission is to make these algorithms to these good algorithms. This is the data structure and algorithm target and goal. So this is your mission. You need to reduce the O notation, the order of the function of the algorithm to the least thing that you may you try to make it lower n. So we start from bigger n and we need to decrease it to lower. Big O visualization. O of g of n is the set of functions with the smaller or the same order of growth as g of n. For example, if we have a O of n squared, this means it includes O of 1, O of n, O of n log n that we have seen in the chart before. So, analyze the algorithm at a larger values of n only. What this means, below n0, we don't care about the rate of growth. For example, if we took O of 1, this means it's 100, 1000, 200, 120. This group of numbers will be considered O of 1 because we don't have any n. The largest thing here is 1000, which is a constant, and it is not multiplied by anything. So it is O of 1. Another example is O of n. These numbers, we have 3n plus 100, 100n, 2n minus 1, and 3. The largest order between these numbers is the n. So this is the n, this is 100n, and the largest order is 1. So n to power 1, it is n. It is denoted by O of n. Okay? Now, another example, O of n log n. 5n log n plus 100, this is the first term. The second term, 100n, 2n minus 1, and 3. 3 is a constant. This is the least one. We have n, but we have here 5n log n. So n log n is greater than n. So it took O of n log n and not n. Okay? So this is n log n. I will show you at the end of this video a memorization for the chart, and I will show you why we are doing this and the proof of these calculations. O of n squared. So if we have numbers and we need to get the complexity of them and the highest degree of them, 3n plus 100, till now we have n. 100n, we have n. 2n minus 1, we have n. So we neglect these and we keep on the greatest order, as I told you. N squared minus 2n, so we have now n squared. So it is n squared. And now n squared here alone, so it is n squared. The greatest one among these is n squared. So we took it as its big O notation. Okay? I need from you to register down and to write down on your copybook that O of n is smaller than log n, is smaller than O of n, is smaller than n log n, smaller than n squared, smaller than 2 to power n, and smaller than n factorial. So please write down 1 O of n or O of 1 less than log n less than n less than n log n less than n square and less than 2 to power n and less than n factorial. Okay? This is the target of big notation, big O notation. And this is that what I need from you to understand and to memorize well, because all of our complexity works will be. Hello, my friends, and welcome to exercise number 1. We are going to deal with the big O. So we need to find the upper bound for the function f of n. The first function that we have is 3f of n equal to 3n plus 8. Okay? This is the first function. We need to find the upper bound of this function. Okay? If we look on this function, what is the highest order of this function? We have two terms, the 3n and the 8. Okay? 3n, and here n at 8 times n to power 0, and here n to power 1. So n to power 1 is greater than n to power 0. So we took n to power 1 as the biggest symbol. And 3n plus 3n1, this means we remove the constant, and 3n plus 8 is less than 4n, because 3n plus 8 is less than 4n. If we neglect 8, 3n is less than or equal to 4n. It's true. And n, now we remove the constants. N is the notation O of n for the 3n plus 8. Okay? With c is equal to 4, c equal to 4, and n0 equal to 8. Okay? This is very important to understand. This is the first example. Don't worry, we will clarify in the next exercise. If we have the second function, f of n equal to n squared plus 1. What is the highest order of this function? We have two terms, n squared and 1, which is multiplied by n0. So we took n squared. N squared plus 1 is less than 2 to power n squared, because we neglect this and we add 1 to the same order. Okay? So n squared plus 1 less than or equal to power n squared, to power or n to power 2. Okay? For every n greater than 1. Therefore, the big O notation of this function is equal to n squared. It's very simple. We are just getting the highest order of the function, the highest n order of the function. Okay? And the c is equal to 2 here, 2, and n0 is equal to 1. This is the constant. It's very simple. Okay, guys? We are going also to make an example 3. So, find the upper bound for the function n to power 4 plus 100n square plus 50. Okay? So, please guys, think about it. This function f of n contains n power 4 plus 100n squared plus 50. How to solve this? How to find the upper bound? In the same way, look at this function. We have three terms, 1, 2, and 3. What is the highest order of this function? What is the highest n order of this function? We have n to power 4. Okay? So what is multiplied by n to power 4? It is 1. So this function f of n is less than or equal to, we increase the one that multiplied by n to power 4 by 1. 1 plus 1 is equal to 2. And the highest degree is n to power 4. Okay? So this function is less than 2n to power 4. Okay? And n square here is the highest function. So O of n of this function is n to power 4. And the constants that we have is there are c equal to 2, because we have multiplied or we have added 1 to the one that multiplied by n to power 4. So this is equal to c, or this will determine the c, and n0 is equal to 11. Now, we don't care about these constants and n0s, because our all concentration about O of n, okay? So I need from you to understand how to create or how to get O of n for every function, okay? O of n here, it is O of n, okay? This is the complexity. This is the big O notation. Another examples. Consider the function f of n here equal to 2n cubed minus 2n squared. We have 2n cubed minus 2n squared because we have two terms here. The highest term is n power cube. Since we have 2n cubed minus 2n squared, so n cube 2n cube is being decreased. So this function 2n cube minus 2n squared is less than or equal to n cube. We don't need to put here 3n like here. No, we don't need about to make this. We need to put 2n squared, 2n cube, okay? Because 2n cube is decreased by minus 2n squared. So remember, take an example, n equal to 1. 2 minus 2 times 1 minus 2 times 1 is equal to 0. Is equal less than or equal to 2? Yes, because 0 less than 2. I substituted 1 inside this. We don't care about this function. We only care about the big O notation of this function. It is O of 3 because it is the highest degree. Okay, this is the big O notation of this function, where c is equal to 2, is the constant, and n0 is equal to 1. Okay, now another two examples that we are going to make in this exercise. Find the upper bound of f of n equal to n. N here is the only term that we have in this function. So n is less than or equal to n. So it is of big O notation, O of n notation, okay? With c equal to 1, the constant equal to 1, because c is n is multiplied by 1 here, and n0 equal to 1. It's very simple. Let's choose another example. F of n equal to 410. 410 is less than or equal 410. Okay, it's very simple. 410. Now, this For all n greater than 1, this means 410 is equal to O of 1. So this is the O of 1. This is the notation of O of 1. Okay? We C equal to 1 and N0 equal to 1. So what we have done in this exercise is understanding the big O notation calculation for this for these functions. So how to calculate the O of n, how to get the highest degree of O of n in this exercise. So we have solved these O of n notations. It's very important to understand these and to learn about the O of n notation. And in the next videos, we are going to learn more about these notations and work with more exercises. So don't worry, we are going to make this very simple in the next videos when we deal with the complexity. So what I need from you to understand that big O notation for any function is the highest degree that it contains inside. Similar to the O discussion, this notation gives the tighter lower bound of the given algorithm, and we represent it by f of n omega g of n. So omega notation is giving the lower bound, and the O notation giving the upper bound of an algorithm or a function. That means at larger values of n, the tighter lower bound of g of f and f of n is g of n. For example, if we consider f of n equal 100 n squared plus 10n plus 50. If we need to consider the O of n, O of n for this function is the highest value is n squared. And the omega notation for this is O of n squared. And it is of O n squared. Okay, omega n squared, because it is the tighter lower bound. So the omega notation can be defined as omega notation of g of n equal to f of n. There exists positive constant c and n0 for the function where 0 between and the function of g of n between 0 and f of n. So there 0 equal less than or equal g of n times c less than f of n. Okay? Our objective is to give the largest rate of growth of g of n, which is less than or equal to the given algorithm rate of growth. For example, if we have here give a lower bound of like f of n squared, okay, give lower bound of f of n equal to 5n squared. Okay? The upper bound here is n squared. Okay? The lower bound, there exists c n squared and n0 such that 0 less than or equal c times n squared less than 5n squared. So there exists n0 and c such that c times n squared less than 5n squared less than f of n. This is the function that and this is the formula that we are working to find the lower bound. Okay? cn squared less than 5n squared. So c equal to 5 and n0 equal to 1. So the the omega notation of this function is n squared. It is the same. For some examples, it is the same as the O notation, but it's very simple. We can consider this as a function, and we are going to work with in many ways.